Welcome back to Pre-Calc. This is the second portion of the 2-1 lesson. We have already reviewed our basic quadratic functions. We've already done some analyzing of the quadratic functions. We've looked on Desmos how A and H and K impact the movement of it, and we've also talked about standard form of the quadratic functions in our new textbook are going to be. We're going to continue in this portion of the lesson on analyzing the graphs. We're going to do a little bit more of analyzing graphs of quadratic functions. We're going to write quadratic functions in standard form, keeping in mind our new standard form of polynomial expressions and quadratic equations. And then we are going to sketch the graphs in standard form. So yes, we've already looked at some of this in part 1, but we're going to go a little more in depth here in part 2 of the lesson. So moving forward, this is an equation that you would have received even in intermediate algebra. I could have asked you to do almost any of those things in intermediate algebra. It's a matter of recalling what is it that we were supposed to do here. So now what I ask you when I'm with you in class is, what's this going to look like if it's graphed? And most of the time you guys will tell me a U or a frown. And that is correct because this is quadratic. The way we know it is quadratic, we've got a degree of 2. Our highest degree is 2. So we know that this is a quadratic equation. We also know that since we only have one squared variable, this is not going to be a circle, ellipse, hyperbola like we dealt with last year. This is a parabola. This is in our old standard form, however. So since it's in the old standard form, we have to remember, how do we go about the old way of finding the vertex? Hopefully you recall that we did that opposite of, I'm pausing to see if you can recall, opposite of something over something. And hopefully you remembered it was x equals the opposite of b over 2a. And so since b, being the second coefficient here in front, b is 2, so we're going to go x is opposite of 2 over 2 times -1 being our a coefficient. So we end up with 1. So x is 1. Now that is h when we put this into regular standard form. That is the x coordinate of our vertex. Well, you may recall a vertex needs an x and a y. It's a point, it's a location. So we have to put the 1 right back in. So I'd come in and I'd evaluate my function at 1 is equal to opposite of 1 squared plus 2 times 1 plus 5. And so we get -1 plus 2 plus 5, and so that's going to give us 6. So the function evaluated at 1 is 6, which makes my vertex at 1, 6. If the vertex is at 1, 6, that automatically tells me where my axis of symmetry is located. Because it's the x that is squared, I know that this opens, actually it opens down because a is negative, and so my axis of symmetry is going to be at x equals 1. So x equals 1 is the equation of the axis of symmetry. And axis of symmetry. And then if we wanted to find our x-intercepts, we also worked on this last week, those are going to be our solutions, our roots. And so our x-intercepts, that is where we let y equal 0. Now I know because the degree is 2, I could have a maximum of 2 roots. They're either going to be 2 real, or maybe this thing is not going to have nice solutions, because recall, it could either open above the axis, that would be no real solutions. It could have its vertex sitting exactly on the axis, and that would be one solution, or a parabola can pass through, and that would be our 2 real solutions. So we just want to decide which type of solution are we going to get with this one. I'm going to choose to go 0 equals opposite of x squared plus 2x plus 5. It's not going to factor. So we're back into x equals opposite b plus or minus, this is quadratic equation. I'm not going to do the whole song because I'm being recorded and I'm not going to do that. But so it's x equals opposite of 2 plus or minus the square root of b squared, which is 4, minus 4ab all over 2a. And we get the discriminant part first. So this is 20 plus 4, that's 24. So negative 2 plus or minus the square root of 24 all over negative 2. So my x-intercepts, this I can simplify on down. I know my factors of 24 are 4 and 6. 4 has a square root in it, so I have negative 2 plus or minus 2 square root of 6 all over negative 2. Simplifying it, we get 1 plus or minus. Actually, I was about to do the negative, but I don't need to do that because of the plus or minus on there. Square root of 6. What type of solution is that? Are we looking at an integer value? Are we looking at just real answers? And this one is irrational because square root of 6 goes on and on and on and on and on forever. So this would be 2 irrational roots, but they're still real. So this is an example of a parabola that's going to go like that, just not going to cross the integer values. All right, continuing on from there, I just re-summarized this onto another page. This is our equation we're working with. Got the vertex, the axis of symmetry, the x-intercepts are going along there. And I did get decimal values. I'm going to have to sketch the graph anyway, so I'd prefer to have some x values. If I want my y-intercepts, remember that is where it crosses the y-axis. So I'm going to put 0 in for my x. Ooh, I have x equals. That needs to be y equals, or f of x equals, sorry. So I am going to put 0 on in. So y is equal to 0 squared plus or minus 2 times 0 plus 5. So 5. My y-intercept is at 5. If I want to sketch the graph of this very quickly, my vertex is going to be at 1, 6. 1, 2, 3, 4, 5, 6. And then I know I have x-intercepts at about 3.5, very close to 3.5 anyway. So right there, and very close to negative 1.5. So about there. I could go get other values. I know it's supposed to open down, and I know I have a y-intercept of 5. So there, oh, I didn't do a very good job of getting that curved, but you get the idea of the parabola opening down. I know I had mentioned finding the focus and the directrix, which we did work on last year. That's going to come back for us in chapter 10. And looking at time today, I'm not going to have you do that. I have amended that. But we do still need to put this into standard form. We don't yet have this in our standard form of our equation. So we need to get it into y equals a times x minus h squared plus k. Vertex form, so it's or standard form now, so it's easy to see our vertex and graph from there. So a remains the same. A is my negative 1. So I'm going to just have negative 1 there, or a negative. And then it is x minus, this is h, 1 squared plus 6. This one is k, because we have h comma k when we go through and do our directrix. And there you have the equation for the parabola in standard form. I just pulled up another example and did all the work, so you can pause this and look at it until it makes sense to you, but I did come in and I found my vertex, so I did the opposite b over 2a and I got 4, so that is h. Plugged it in and I got my negative 16, so my vertex is at 4, negative 16. I know it opens up because a is positive, and I also know it's going to be wider because a is a fractional value. It is less than 1, which is going to stretch it out and make it a wider parabola. Axis of symmetry is at x equals 4. My x-intercepts, this time because the degree was 2, I was going to have 2 roots. They are both real integer values this time. I factored it and it worked, so 12 and negative 4. And my y-intercept is at negative 4. I sketched in the axis of symmetry, put the vertex on, And then I sketched all the other points, and there I have it. The only thing left to do, which is what you are going to have to do in this section, is, again, we want to write the equation for this parabola in standard form. So it's going to be y, or f of x, is equal to a, and a was the 1/4, and then x minus h, which is 4 squared, plus k. So there's h and k again. It all has to do with your vertex. Another item we are going to be asked to do in this section is to write the standard form of an equation for a parabola given a vertex and a point. Well, these are not so bad, because if we just recall that y is equal to a times x minus h squared plus k, there's h, there's k, this is just an x, and this is just a y. X, y. All we're going to do is plug those values in. The only thing we don't know is a, so we do need to solve for a. So we're going to have y is 2 equals a, x is 1, h is 3, k is 4. So I end up with 4a plus 4 equals 2. Negative 2 equals 4a, or a is negative 1/2. Now I know enough to write the equation in standard form. Y equals negative 1/2 x minus 3 squared plus 4. Notice the h and the k come back in because those are going to remain consistent for the entire parabolic system there. Actually, it's not a parabolic system. It's just a parabolic equation. It's just for all points in this one parabola. That is going to be the equation. Now, I think time-wise, that's about all I'm going to try to fit in for today. So we do still have some other examples. I was going to run through a couple more, and some with a little bit harder points to try to work on, but it's all going to follow the same procedures what I did on the one before. And then we've got a couple real-life examples that we will come back to tomorrow. So I will be back to help you. Do the best you can. Go to Google Classroom and find your assignment. Good luck.